Hello guys, welcome to the DMS online school. In today's lesson I will be teaching you on a topic called qualitative analysis. So qualitative analysis is a topic in chemistry. Alright, so let's go straight into the day's lesson. So what is qualitative analysis? So we are saying qualitative analysis is a topic which deals with the identification of the composition of compounds through careful observation and inferences. So just like we have food test in biology, also in chemistry we have a topic known as qualitative analysis, which we use to identify the composition of unknown compounds. Alright, so we are saying it involves making observation of colors of solids, liquids, or gases formed in chemical reaction. In this topic, we shall deal with the identification of positive and negative ions of ionic compounds in aqueous state. So positive charged ions are called cations, while negatively charged ions are called anions. Alright, so let's start with identification of cations. So the cations are identified by testing them with reagents such as aqueous, sodium hydroxide, and the ammonia. So we use sodium hydroxide and the aqueous ammonia to test for cations in compounds. Alright, so examples common cations, or rather examples of cations commonly identified are calcium, then aluminium, then ammonium, zinc, iron 2 and iron 3. Alright, so these cations form precipitates of specific colors when reacted with aqueous, sodium hydroxide, and the ammonia. So these these cations listed here, when they are reacted with aqueous, sodium hydroxide, or ammonia, they form precipitate of solids or insoluble substances of specific colors, meaning calcium will have its own color, aluminium its own, ammonium its own, zinc its own, iron 2 its own, and iron 3 its own, when they are reacted with these reagents here. Alright, so let's look at the steps involved in performing qualitative analysis. Excuse me. So we are saying a well-labeled compound whose cations is to be identified is placed in 2 separate test tubes. Alright, so to one test tube containing the compound, few drops of aqueous sodium hydroxide solution are added and observation of any changes are recorded accordingly. Then to the other, or to the same test tube, excess aqueous sodium hydroxide is again added and observations of any changes are recorded accordingly. Alright, then to the other remaining test tube containing the compound, few drops of aqueous ammonia solution are added and the observations of any changes are recorded accordingly. To the same test tube, excess aqueous ammonia solution is added again and the observations of any changes are recorded accordingly. Alright, so the recorded results from the 2 tests performed are then compared on a data sheet to see what the cations are present in the compound, or to see the cations present in the compound. Alright, so this is the data sheet that we use when carrying out qualitative analysis. So in this data sheet, we have the names of the cations here. Then we have the effects of aqueous sodium hydroxide on such a compound. Then here we have also the effect of aqueous ammonia on the unknown compound. So here we treat these compounds as the unknown compounds containing certain cations here. Alright, so this table is the most complicated table, and it needs to be taught to you for you to be able to use it, because it was written in a way that was not very clear. Alright, but I will labor the most to explain what it means. So here what it is, it has this white precipitate and there's a comma here. So there are 2 things involved here. There's a test for few drops, when few drops of sodium are added, for example, to the compound. the result that are seen, or the effect which is seen, is given by this result just here, white PPT. PPT stands for precipitate. Then after full stop here, there's another result, and this result written here is for the second test where excess sodium hydroxide is added to the compound. So when excess is added, the same white precipitate here, white precipitate soluble in excess, giving a colorless solution. So this one you read, the first time they put a few drops of sodium hydroxide to this, then the result should be that the results or the observation is that white PPT. That's what they give. Then when again excess sodium hydroxide is added here, then the result includes reading it from here up to the end. So you say white PPT soluble in excess, giving a colorless solution. So the same way this side. So to the other one, where to the other portion of the compound again, where you add the aqueous ammonia. Again, this result which ends here is for the first time you add a few drops to that other portion of the compound. Then this other one combined with this is the result that is seen after adding excess ammonium to the same compound where a few drops were added. That's how this table works. So now let's say those tests that I explained previously, where I said a compound whose cations are to be identified is divided into two portions. Then the first portion, they add few drops of aqueous sodium hydroxide. Then if the observation made is that white PPT is observed, then again when excess aqueous sodium hydroxide is added again to the same compound, to the same portion of the compound, and then white precipitate that was formed now is soluble in excess, giving a colorless solution. Then also to the other portion that was given in another test tube, you add again few drops of aqueous ammonia, and you observe that a white PPT is formed. Again, to the same one you have added few, now you add excess aqueous ammonia, and then you see that that white PPT now is insoluble in excess, or it remains as it were in the first place when you had to put few drops. Then that compound having these results here and these, then it will be expected to contain ammonium ions. Ammonium ions will be the one in that compound that you were testing. All right, so the cation present in that anion compound are ions. Similarly here, if you added to this compound here, you added aqueous sodium hydroxide, and then on warming the same compound, ammonia gas produced on warming, or ammonia gas is produced on warming, and then maybe you add aqueous ammonia to the same, then nothing happens. Then what we are going to conclude is that that anion compound contains the cation ammonium ions. Again, similarly, if you get aqueous sodium hydroxide added to the anion compound, few drops, and then a white precipitate is formed. Then to the same where you added few drops, then you continue adding now excess sodium hydroxide to the same portion of the compound where you added few, and then after adding excess, that white precipitate is insoluble, or it remains undissolved. Then it remains undissolved. Then again you get aqueous ammonia to the other portion that you shared. You add again few drops, again you observe no change, again you add excess, again you observe no change. Then that compound that you were testing contains calcium ions as the cations. Then also if you get aqueous sodium hydroxide, you add it to a portion of an unknown compound, and then you see a light blue precipitate formed, and then to the same way you added a few drops, then you add now excess sodium hydroxide, and then you see that that light blue precipitate now remains insoluble in excess. And then to the other portion again, because you divided this one into two, to the other portion you add again a few drops of ammonia, aqueous ammonia. Then you see again a light blue precipitate. Again you add to the same way you added a few drops of ammonia, you add now excess of aqueous ammonia. Then that light blue precipitate now is now soluble in excess, giving a dark blue solution. Now you make a proper conclusion of saying that compound now contains the copper ions. All right. Again, if you have another unknown compounds where you add few drops of aqueous sodium hydroxide, and then you see the result that a green precipitate is formed, then to the same one where green precipitate are formed, then you add excess sodium hydroxide, and then the green precipitate now is insoluble in excess, or it does not dissolve. Then again to the other portion that you shared, again you get a few drops of aqueous ammonia, you add to it, and then a green precipitate is formed. Again to the same way a green precipitate is formed, you add now excess ammonia, and then that precipitate, that green precipitate stays undissolved, or it is insoluble in excess, then it turns reddish brown on standing. Then you are going to conclude that that whole compound you were testing now contains the ion 2 ions. All right. Then if you have a compound again unknown, to it you add aqueous sodium hydroxide few drops, then you see around a red brown precipitate. Again to the same way you saw red brown precipitate, now you add excess sodium hydroxide, and then that red brown precipitate remains undissolved or is insoluble in excess. Then to the other one you shared, a portion you shared, again you test with aqueous ammonia. Then after testing with aqueous ammonia, then the red brown precipitate is seen. Then that red brown precipitate, after adding to it again excess ammonia, it remains insoluble in excess. Then you must conclude that that unknown compound contains the ion 3. All right, it contains ion 3. So if again you have a unknown compound, again to that unknown compound, if you add a few drops of aqueous sodium hydroxide, then a white precipitate is seen. Then to the same way you added, you saw a white precipitate. Now you decide to add excess sodium hydroxide, and then that white precipitate now is soluble in excess, giving a colorless solution. Then to the other portion that is not yet tested of the same compound, you test again with the aqueous ammonia, where you add a few drops of aqueous ammonia, and then you see white precipitate. Again to the same way you have seen white precipitate, now you add excess. Not here you added few drops, now here you add excess aqueous ammonia. Then that white precipitate again is soluble in excess, giving a colorless solution. Then that compound contains zinc ions. All right, so this is how this table works. The way I've explained, that's how it works. If you cannot understand it in that way, then you'll never manage to use this table to analyze the results. So let's look at now test for anions. So anions now, they differ a bit with the cations. So they can use just one reagent or two reagents. Then there's no need of adding excess as we were doing with the cations. So for instance, if you have a known substance here, then to it you add dilute acid. Then you see if absence occurs or bubbles occurs, then carbon dioxide is produced. We expect that those bubbles are for carbon dioxide. Then that substance contains the carbonate anions. All right. So again, if you have a known substance like here, then to it you add you acidify with dilute nitric acid, then you add aqueous silver nitrate, and then you see a precipitate to this guy here. Then that one contains chloride ions. All right. Then if you have another unknown substance, then to it you acidify with dilute nitric acid, then add aqueous lead to nitrate, then you see a yellow appearing in this guy, then that guy contains iodine ion. Then if you have another unknown compound, to it you add sodium hydroxide, aqueous sodium hydroxide, then aluminium foil, then you warm carefully to it. If ammonia gas is produced, then that contains nitrate ion. Then if you have another compound, to it you acidify with dilute nitric acid, then add aqueous barium nitrate, then you see a white precipitate formed. Then to that unknown substance contains sulfate ions. All right. So now, having explained the theory that is involved in analyzing the results, then let's see the actual question that you may encounter in an exam. So we have this question here which says, in this practical assessment, you will determine the actual name of the compound in sample solution Y by identifying the cation and anion present in aqueous sample solution Y using qualitative chemical analysis. Then you are provided with the following chemicals and apparatus. So you have sample solution Y, dilute sodium hydroxide solution, dilute ammonia solution, dilute nitric acid, dilute barium nitrate, 3 test tubes labeled A, B, and C, 4 droppers measuring cylinder. So we push it here so that we show you sample solution Y, how it is given to you. It may be put in a beaker and be labeled sample solution Y. Then dilute sodium hydroxide may be put in a conical flask and be labeled sodium hydroxide like that with a dropper either inside there. Then you may be given also ammonia. It can be given the name like this, or it can be given a chemical formula like this with its own dropper. And then you can be given also barium, nitric acid, also like that, and then 3, and then barium nitrate like this. And then you may be given now the 3 test tubes that have been labeled like that, and then a measuring cylinder. So you may be given these in such a question. Then instruction will be given like this: put 3 ml of sample solution Y to each of the 3 test tubes and carry out on each of them the following tests and record your observations in the table below. So you may have a table like this one, where now you have the test number here, and then you have the tests that you carry on A, the test on A again, the test on test tube B, on test tube B, on test tube C, on test tube C. So here what they've told you is to put 3 ml of sample solution Y to each of the 3 test tubes. So what you do, the 3 test tubes that you have been given here, you get sample solution Y, 3 ml, you measure using a measuring cylinder. 3 ml you put in this one, 3 ml in this one, 3 ml in this one as well. Then after you do that, now you go ahead and start carrying out these tests here. So let's now start these tests together. What can be done? So you go to test number 1. What are you supposed to do? They are saying add 3 drops of nitric acid to test tube A. So let's bring test tube A containing a sample solution Y. So this is test tube A containing sample solution Y. To it we should add nitric acid. So we'll get some drops of nitric acid, 3, they've told us 3. So we add the 3 drops of nitric acid and make observations. So from the observation that we have made here, let me just repeat. So you see, have you seen any change? No change. So we'll record here, no change is observed. All right, then test 2 says add 3 drops of barium nitrate to the same test tube A. So to this same test tube A, now we add the barium nitrate. So we'll bring now barium nitrate and then get barium nitrate and add how many drops? 3 drops. So add the 3 drops of barium. Observe what is happening. Let me repeat. So these you observe first before adding, then after you add you observe. So observe what is happening here. So those are 3 drops, you see. So they are white things that have been formed, white solids. So record here that white PPT is formed, which means white precipitate is formed. That's what we have seen. Then test 3 says add 3 drops of aqua sodium hydroxide to test tube B. So now we are going to test tube B. So we'll get test tube B again here, to which now we should add the aqua sodium hydroxide. So we'll get the aqua sodium hydroxide here, and this aqua sodium hydroxide we should add 3 drops in this one. So we'll get 3 drops and add and see observation again. So you have seen what has happened. Before adding, it is like this. After adding 3 drops, you see what happens. We see some white solids again. So we'll record it as white precipitate is formed. You record what you are seeing. Then we go to test 4. Test 4 is saying now add excess sodium hydroxide to the same test tube B. So to the same test tube B here, now we add excess. We added 3, now we add excess. So let's add excess, all right? So we may add excess here. We see what can happen, a lot of it. You have seen? So whatever the solids, let me just repeat. So you see there are solids here that we recorded here. Now to the same one where we have seen white precipitate, now we need to add the excess. So we add excess, we see a lot of it now, more than 3 drops now, you add a lot. So observe what is going on, you see. So now the precipitate have dissolved. So how do we record? We say white precipitate is soluble in excess, giving a colorless solution. So it has given us a colorless solution. We record it like that. Then we go for test number 5. Test number 5 says add 3 drops of aqueous ammonia to test tube C. So we get test tube C here and bring it here. Then to test tube C, we should add the aqueous ammonia. So we'll add aqueous ammonia to test tube C. So we'll add how many drops? 3. So observe how it is appearing. So you add 3 drops. What have we seen? White precipitate. So you record white precipitate is formed. Then you go to test tube to test 6, which says now add excess aqueous ammonia to the same test tube C. So now you add excess here to the same, more than 1 drops, enough now. See what will happen to the solids. They have again dissolved. So you are going to record the white precipitate is soluble in excess, giving a colorless solution. So these are your results now that you have now collected. Now you need to analyze them to know what is in sample solution Y. That you had to put to 3 test tubes that you were labeled A, B, C, and to each one of them A, B, C, you have done these tests. All right, so you get your result. These are your results. Now you start analyzing them using the data sheet. So now you begin with these. So these, where you use the nitric acid and the barium. So you were not testing for cations, because cations are tested using sodium hydroxide and the ammonia. So are tested using aqueous sodium hydroxide and aqueous ammonia. Now, since we never used these are for anions. So we'll get a table or data sheet for anions and use it to analyze these results to tell us what anions are in sample solution Y. So what we'll do, we'll get this table here, test for anions that I told you already. So here they are saying add dilute nitric acid if the results show effervescence occurs, carbon dioxide produced. Did we see effervescence when we added the dilute nitric acid here? Here when we added the 3 drops of nitric acid to the test tube, as we didn't see change. So since we didn't see change, then we are not expecting us to have the carbonate as an ion. Then we go to number 2, acidify with dilute nitric acid. We added nitric acid, then add the aqueous silver nitrate. No, we never used silver nitrate in our test. So this one, again, we are not going to waste our time on it. Then we move to this one, test. Acidify with dilute nitric acid. Yes, we added nitric acid, then add aqueous lead to nitrate. We never used the aqueous lead to nitrate. So this one, again, we never carried it, so we'll not waste our time on it. Then we go to this one, add aqueous sodium hydroxide, then aluminium foil. We never did such a test, so this one, again, we'll leave it. We will not waste our time on it. Then we'll go to this one where it says acidify with dilute nitric acid. Then we added some, yes, we added some nitric acid. Then add aqueous barium. Yes, we also used aqueous barium. Then they're saying when you do this, then you see white precipitate. Yes, we also saw a white precipitate here. Here, when we added the 3 drops of nitric acid to test tube A, we didn't see any change. To the test tube, to the same test tube A, we added the 3 drops of barium nitrate, and then what we saw was a white precipitate. Now we have concluded, since our precipitate here and ours which we saw, they are matching, then it means that since we are getting this result, then it means the compound solution Y contains the sulfate ion here. Sulfate ion, you have seen this sulfate ion. This one will record now here that sample solution Y contains the anion sulfate. So we have identified one. So now the next thing is to identify the second one. We are done with the anion. Now we go to the cation where we added aqueous, sodium hydroxide, and where we added ammonium hydroxide. So we'll get the same table. We'll bring the same table here. So the same table that I was explaining. So we'll start with the effect of aqueous sodium hydroxide. All right. So here they are saying if you add a few drops of sodium hydroxide to a solution, and then you see a white precipitate, like here when we added the few drops here, like 3 drops of aqueous sodium hydroxide to test tube B where sample solution Y was, we saw a white precipitate. Then let's see another one here where they are saying soluble in excess giving a colorless solution. So when you add now excess now to the same one where we have seen a white precipitate, that white precipitate will be soluble in excess giving a colorless solution. Even as here when we added in the next where they said now add excess aqueous sodium hydroxide to the same test tube B. When we added, we saw that the white precipitate is soluble in excess giving a colorless solution. So you see this one qualifies. So this they are testy and ours they match. Then let's see where now you use aqueous ammonia. So when they use a few drops of aqueous ammonia, a white precipitate is formed. Even as here when we used 3 drops of aqueous ammonia to test tube C, we saw a white precipitate. All right. So now, here now, again, when they add the excess, they are saying white precipitate insoluble in excess. So let's see as the white precipitate if it is insoluble. So as when we added the excess, now add excess aqueous ammonia to the same test tube C. When we added the excess, what did we see? White precipitate is soluble in excess, giving colorless solution, a colorless solution. So when we look at this, we come to the result here. The result is insoluble, so it is not matching. So since we are not matching here, then our solution Y does not contain this cation. Then let's come to this one where they are saying effect of aqueous sodium hydroxide. When it is added, ammonia gas is produced on warming. We didn't do any warming, so this one will skip it. We'll move to this one. When you add aqueous sodium hydroxide, white precipitate is seen. Then there's an insoluble in excess. We didn't see an insoluble here, so this one we ignore it. Then this one, light blue precipitate or PPT, we didn't see a light blue, so this one we ignore it as a whole. This one, green precipitate, we never saw a green precipitate, so this whole thing we ignore it as a whole. This one, red brown precipitate, we didn't see a red brown precipitate, so this one as well we ignore it as a whole. This one, white precipitate, we saw a white precipitate here. Let me show you that we saw it when we added the few drops of aqueous sodium hydroxide. So here, when we added the 3 drops of aqueous sodium hydroxide to test tube B, we saw that the white precipitate was formed. So just like this result here, few drops white precipitate is seen. Now when excess is added to the same, we see that white precipitate is soluble in excess, giving a colorless solution. Even as here, when we added here in 4, where they said now add excess aqueous solution, aqueous sodium hydroxide to the same test tube B, we saw that the white precipitate that we saw was soluble in excess, giving a colorless solution. So this result now is already matching with ours here. Now let's see this other one where you use aqueous ammonia. So here, when we added the 3 drops of aqueous ammonia to test tube C, we saw white precipitate. All right, so let's see also here what happens when a few drops are done, what are added. So few drops, when they are added, a white precipitate, yes, is seen just like us. All right, so when we added excess, now add excess aqueous ammonia to the same test tube C, what we saw, white precipitate is soluble in excess, giving a colorless solution. All right, so let's also see what happened here. Here also, when you add excess, they're telling us soluble in excess, giving a colorless solution. So this one has matched with us, both with aqueous sodium hydroxide and aqueous ammonia hydroxide. Hence, since this one has matched with our results, then the sample solution Y contains the zinc ion. So we'll say that sample solution Y contains the cation zinc ions. All right, so let's now move a bit here. We have already identified the anion and the cation. All right, so what we are saying now is that zinc was in the sample solution plus what? Plus the sulfate. So these two combined, they give us zinc sulfate. So meaning that sample solution, therefore, sample solution Y is zinc sulfate. We have identified it that it was zinc sulfate. So the chemical equation for this one will be zinc ion plus sulfate ion will give us the zinc sulfate. All right, so this is how we do qualitative analysis. I hope you have learned something on qualitative analysis. So give this video a like. If you haven't yet subscribed, consider subscribing, and also turn on the notification. For online tuitions, you can contact me on the line appearing on the screen. As for now, bye and see you in my next video. Peace.